Hello students, welcome back to the maths class. In today's class, we are starting with a new chapter, three-dimensional geometry. Okay, here the first concept which we are going to learn is direction cosines. Yes, this direction cosines we have already learned in vector algebra. Why again we are learning direction cosine means here we are taking with respect to line. There we have seen a direction cosine with respect to a vector. A vector is what? A vector is a directed line. So let us learn and also understand what is the difference here and what was the difference between the direction cosines which we have learned in the vector algebra and what is the direction cosines which we are learning in three-dimensional geometry. So if you see, if OP was a vector, we have considered the OP vector. This OP vector is making an alpha, beta and gamma angle with the positive direction of x, y and z axis. So we called this alpha, beta and gamma as directed angles, and hence we called cos alpha, that is the cosine of this angles, that is cos alpha, cos beta and cos gamma as direction cosines. Yes, which we also call it as L, M and N. Okay, with the other representation of cos alpha, cos beta and gamma is L, M and N. So this was the thing which we are studying. Here, what we are doing is we are considering a line. So when we consider a line, the line can have a direction in both the ways. So if the line L you have, it can have a direction in both the ways. So when it has a direction in both the ways, here you can see the line L is making an alpha angle, beta angle and a gamma angle with the positive direction of x, y and z axis respectively. And also it makes pi minus alpha, pi minus beta, pi minus gamma with x, y, z axis again. So here from this what we can conclude is if alpha, beta and gamma are the angles, even we should consider, see I have taken only the x-axis in order to make you understand, this is the line L, so this is alpha means, even since we are considering the entire line, it also makes pi minus alpha. Okay, so here with the positive direction of the x-axis, so here we have two angles, that is alpha, beta and gamma, and also pi minus alpha, pi minus beta and pi minus gamma. So from this what we can see is we get two direction cosines. That is means if I take cos of these angles, that is cos alpha, cos beta and cos gamma. Here it will be cos of pi minus alpha, cos of pi minus beta and also cos of pi minus gamma. That is nothing but L, M, N and minus L, minus M, minus N. This is the simple difference between what we are studying in vectors and what we are studying with respect to line. In vectors, we have considered a vector. Vector algebra, we have considered a vector. It is a directed line. You have got one direction, but here in the line, so here we have two direction cosines. So for a line, we will be having a set of direction cosines, that is L, M and N, and also minus L, minus M, minus N. So remember, for a line, we have set of direction cosines, that is plus or minus L, okay? Plus or minus M, plus or minus N, or you can take it as L, M, N, and even minus L, minus M, minus N. Why? Because see here the line L is making two angles. One is alpha and one is pi minus alpha. We are considering both the angles here. So when I consider both the angles, alpha and pi minus alpha, you need to take the cosine for both the angles. So cos alpha, cos beta, cos gamma, and cos of pi minus alpha, cos of pi minus beta, and cos of pi minus gamma, which is given by L, M, N, and minus L, minus M, minus N. Therefore, you have set of direction cosines for a line. That is plus or minus L, plus or minus M, and plus or minus N. This is about direction cosines. Now next, let us study what are direction ratios. Okay, so if you have direction ratios, we have already studied what is direction ratios in vector algebra also. That is the same thing here also. The three numbers which are proportional to direction cosines, those numbers are called as direction ratios. If A, B, C are three numbers, if they are proportional to direction cosines, then these three numbers are called as direction ratios. Here also the three numbers which I call it as A, B and C, which are proportional to direction cosines, those numbers are called as direction ratios. So A, B, C are called as direction. So here we have set of direction cosines. What happens is the direction cosine only when one set do we have A, B, C. Here we have infinite number of direction ratios. Okay? Not only one set of direction ratios, we can have infinite number of direction ratios. Why? Why? Because we are telling that the three numbers which are the ratios of direction cosine, which are proportional to direction cosines are said to be direction ratio. See, if I consider it as these three numbers as 2 times of 2a, 2b, 2c, again these will be proportional. Okay, same way if you multiply by any number, so you will be having infinite number of direction ratios, but you have only like plus or minus n, plus or minus n and plus or minus n for the direction cosines, but the direction ratios will be infinite number of direction ratios. I hope you have understood with the direction ratios and direction cosines. Why we have two sets here? Because we are considering a line here, but in vector algebra we considered a vector. Since we are considering a line, so we are having two directed angles, that is alpha and similarly pi minus alpha, same way beta, pi minus beta and gamma, pi minus gamma. So we have two sets of direction cosines, which is L, M, N and minus N, minus M and minus N. And the three numbers which we have considered as A, B, C, which are proportional to direction cosines, those are called as direction ratios. Okay, let us find what is the value of L, N and N. So just now we have told that A by N, which is equal to B by N, which is equal to C by N. That is the direction, three numbers A, B, C, which are proportional to direction cosines are called as direction ratios. So this I call it as 1. In vector algebra, we have already know that L square plus M square plus N square is equal to 1. This I call it as equation number 2. From the first equation, see I can write it as AL is equal to K, even B by M is equal to K and C by N is equal to K. From this I can write A is equal to L into K, B is equal to M into K and C is equal to N into K. If I square them and also add, okay, I'm squaring these and also I'm adding. So if I do that, I get A square is equal to L square K square, B square is equal to M square K square, C square is equal to N square K square. Now I am adding all these things, I get A square plus B square plus C square is equal to L square K square plus L square M square, M square K square and N square K square. So we have got K square common. So L square plus M square plus N square. So from this I can write K square because L square plus M square plus N square is equal to 1. This is equal to K square plus B square plus C square. So what is K here? K is nothing but plus or minus root of A square plus B square plus C square. Okay? From the same equation, I can write this as L is equal to A by K. Okay? That is the direction cosine cos alpha, which is L, which is equal to A by K, which is nothing but a divided by, what is the value of a? Plus or minus root of a square plus b square plus c square. Okay, similarly, m, which is nothing but cos beta, which is equal to, so I can directly write this to be as b divided by root of a square plus b square plus c square, and cos gamma, which is n plus or minus c divided by root of a square plus b square plus c square. So these are the direction cosines. Why we have plus or minus? Because we are considering a line here. So here when we are writing the direction cosines, cos alpha which is equal to L, which is equal to a by root of a square plus b square plus c square. Similarly, b plus or minus b by root of a square plus b square plus c square, and plus or minus c by root of a square plus b square plus c square, where a, b, c are the direction ratios and these are the direction cosines. Now we are going to find the direction cosines and the direction ratios of a line passing through 2 points. Okay. So we have considered a line. You have got 2 points PQ. Now what I do is I drop a perpendicular joining R and S. Next I draw a perpendicular and I call this to be as N. Now if you see, you have a right angled triangle here. Okay. Now let us think that this line is extending to z axis, the line PQ. If it is extending, it is understood that the angle made by this line with the positive direction of z axis is gamma. Okay, if this is gamma, then if I draw a line parallel to z axis, if I draw a line parallel to z axis, even this angle will be gamma. Why? Because of corresponding angle. Next, this angle becomes gamma because of alternative angles. Okay. Now, from the triangle PQN, I am going to define what cos alpha is. So, sorry, cos gamma is. So cos gamma, it is nothing but adjacent by hypotenuse. For this angle, this will be opposite, this is adjacent, and this PQ is the hypotenuse. So adjacent by hypotenuse, that is nothing but NQ by hypotenuse. Hypotenuse is PQ. NQ. Okay. So if this is the origin, if I take this, if this is the z-axis, this I call it as z1 and this as z2. Okay, so NQ will be nothing but, if I need to find NQ, this is nothing but the whole Z2 minus of Z1. So this is entire thing is Z2, this is Z1. If I want only this part, that is nothing but Z2 minus Z1. Therefore, this is Z2 minus Z1 divided by PQ. Why I have taken this as Z1 and Z2? Because, see, this P, it is x1, the coordinates of P is x1, y1, z1, and the coordinate of Q is x2, y2, z2. Therefore, here it is z2. P, it is, see, this point of z, it is same here, so it is z1 here. So, cos gamma is equal to z2 minus z1 divided by P. Similarly, you can find it for cos beta and cos alpha. So, from this I can write similarly, cos beta will be equal to y2 minus y1 by pq, and cos alpha is equal to x2 minus x1 by pq. Where pq is what? PQ is the length from point P to point Q. We already know how to find the distance between the 2 points using the distance formula. So this will be equal to root of, what is the distance between 2 points is given by? It is x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Understood? So cos alpha, cos beta and cos gamma are now the direction cosines of the line joining the 2 points. So for the line joining the 2 points, cos alpha is given by x2 minus x1 by p cube, and cos beta it is y2 minus y1 by p cube, and cos gamma z2 minus z1 by p cube, and the p cube is nothing but root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. If this is the direction cosines, what are the direction ratios? For the line passing through the 2 points, the direction ratios will be x2 minus x1, y2 minus y1, and z2 minus z1. With this, we have even x1 minus x2, y1 minus y2, and z1 minus z2. These are the direction cosines. Why with this? Because we are considering line. I am again repeating, here we are considering a line, not a vector. Okay, so these are the direction cosines and this is our direction ratios. Let us solve problems on the direction cosines and direction ratios. I will start the concepts in the form of formulas, so you can make a note of it. Okay. So let us solve the first problem. If a line makes an angle of 90 degree, 60 degree and 30 degree with positive direction of x, y and z axis respectively, find its direction cosine. Means they have given us what is alpha, beta and gamma. So alpha is 90 degree, beta is 60 degree and gamma is 30 degree. We need to find what direction of cosines. Means we need to find what is cos alpha, cos beta, cos gamma. So cos alpha is equal to cos 90 degree. What is cos 90 degree? Cos 90 degree is 0. Then cos beta is equal to cos 60 degree. Cos 60 degree is 1 by 2. Next, cos gamma, which is equal to cos. Here it is gamma value is 30. So cos 30, it is equal to root 3 by 2. Okay, so what are the direction cosines here? It is 0, 1 by 2 and root 3 by 2 are the direction cosines. Similarly, the next problem, again they have given you the angles alpha, beta and gamma which are made with the x, y and z axis respectively. So alpha is 90 degree, beta is 135 degree and gamma is 45 degrees. Let us find what is cos alpha, cos beta and cos gamma because we need direction cosines. Direction cosines are nothing but cos alpha, cos beta and cos gamma. Cos alpha is equal to cos 90 degree, cos 90 degree is 0, cos beta is equal to cos 135 degree. So how to find the value of cos 135 degree, which can be written as cos 180 degree minus 45 degree. Now tell me what is cos of 180 minus theta? It is minus cos theta. So minus cos 45, that is minus 1 by root 2. Next, cos gamma, which is cos 45 degrees and cos 45 is nothing but 1 by root 2. Therefore, the direction cosines here is 0, minus 1 by root 2 and 1 by root 2. Next question, here you need to find what is the direction cosines when the direction ratios of a line is given. So when the direction ratios of a line is given, we already know if A, B, C are the direction ratios, then the direction cosines of the line will be given by the formula L is equal to plus or minus, okay, A divided by root of A square plus B square plus C square, yes. Similarly, M is equal to plus or minus B divided by root of A square plus B square plus C square, and N is equal to plus or minus C divided by root of A square plus B square plus C square. So here what they have given? They have given A, B, C. That is the direction ratios is given. What is the value of A here? It is 2 and B is minus 1 and C is minus 2. These are the direction ratios. Now let us find its direction cosines by applying these values in the formula. This is equal to 2 divided by, here you are not supposed to write plus or minus. This indicates you should take the sign of the given direction ratio. So 2 divided by root of 2 square plus minus 1 the whole square plus minus 2 the whole square, which is equal to 2 divided by root of 2 square is 4 plus 1, and again 4 root of 4 plus 1 plus 4, which is 9, therefore you will get it as 3. Next, now you have minus 1, so you should consider minus 1 here. You should take the sign. Okay, why plus or minus? Again I'm telling, this is because we are taking a line here. So minus 1 divided by root of 2 square plus minus 1 the whole square plus minus 2 the whole square. Therefore minus 1 divided by 3. Next you have minus 2 divided by root of 2 square plus minus 1 the whole square plus minus 2 the whole square, which is minus 2 by 3. Therefore the direction cosines for the line which has a direction ratios 2, minus 1 and minus 2 is given by 2 by 3, minus 1 by 3 and minus 2 by 3. This is how we find the direction cosines when direction ratios of a line is given. Now let us see how to find the direction cosines when they have given the line passing through 2 points. Again, we know the formula. So for here, the direction cosines is given by x2 minus x1 by pq. If you consider this as p and this as q point, then y2 minus y1 by pq and z2 minus z1 by pq. And again we know what pq is. pq is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Now just applying the formula. So this is first point is p, second point is q. Consider the coordinates of point p as x1, y1 and z1, this as x2, y2 and z2. Now, in order to find, first let us find what is the value of pq. So pq is equal to root of x2 minus x1. So x2 it is 1 minus of minus 2 the whole square plus y2 minus y1 the whole square. y2 it is 2 minus y1 it is 4 the whole square plus z2 minus z1 the whole square, that is 3 minus 5 the whole square. So therefore this is equal to root of 1 minus and minus plus. So 1 plus 2 it is 3, 3 square 9 plus 2 minus 4 it is minus 2 whole square, it is plus 4 plus 3 minus 5 it is minus 2 whole square, again it is 4. So 4 plus 4, 8, 8 plus 9, which is equal to root 17. Therefore, what is the direction cosines? Which is given by x2 minus x1 by pq. So x2 it is what? x2 it is 1 minus x1 it is minus 2 divided by pq, which is root 17. Next, y2 minus y1, that is 2 minus 4 divided by pq, which is root 17, and z2 minus z1, it is 3 minus 5 divided by root 17. Therefore, it is 1 minus 2 minus plus, so it is 3 by root 17 and minus 2 by root 17, and you have minus 2 by root 17. Understood? Next question, find the direction cosines of the sides of the triangle whose vertices are. So these are the vertices. I'll take this as A, B and C. So we have a triangle A, B and C. We need to find the direction cosines. Means if this is a line joining the 2 points, I need to find the direction cosines of the line joining the points A and B. Similarly, next we need to find the direction cosines of the line joining the point B and C. And next, find the direction cosines of the line joining the points C and A. So first, what I am doing is, so finding the direction cosines of line joining the points A of 3, 5, minus 4 and B of minus 1, 1 and 2. So what is the formula? x2 minus x1 by, here it is not p2, what you should write? It is ab, y2 minus y1 by ab and z2 minus z1 by ab. And we need to find what is ab. ab is given by root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So this is your x1, y1, z1. Next this you should write it as x2, y2, z2. Okay, therefore this is equal to root of x2 minus x1 the whole square minus 1 minus 3. Minus 1 minus 3 is minus 4. Minus 4 the whole square plus y2 minus y1 the whole square 1 minus 5. 1 minus 5 is minus 4, again minus 4 the whole square plus z2 minus z1 the whole square. Z2 it is 2 plus 4. 2 plus 4 it is 6. 6 square. Therefore this is equal to root of 16 plus 16 plus 36. Therefore this is equal to, you have 16 plus 16 plus 36. So this is equal to root of 30, 40, 50, 50, 62, 62 plus 6. It is 68. So root 68 will be simplified. Root 68, it is, we can write this as 2 root 17. Okay. Therefore, now we need to find what? Direction cosine. So x2 minus x1 by AB, x2 minus x1, that is minus 1 minus 3, that is given by minus 4. Minus 4 divided by 2 root 17. Next, y2 minus y1, 1 minus 5 is again minus 4 divided by 2 root 17. Next, we have z2 minus z1, 2 minus of minus 4, so it is 6 divided by 2 root 17. So what will be the final direction cosines here? It will be 2 by, minus 2 by root 17, minus 2 by root 17, 3 by root 17. Okay. These are simple problems. If you know the formula, you can directly substitute the values and simplify. This is for the line joining AB. Next, what you should do? You should find, similarly you need to find for line joining BC. Means, now you should consider B and C. So B means it is minus 1, 1, 2 and C minus 5, minus 5, minus 2. So you should consider now this as x1, y1, z1 and x2, y2, z2. Here you are going to write BC. Okay. Similarly, you should find it for BC, means direction cosines for the line joining BC, and also for C. This I leave it for your assignments. That is finding the direction cosines for the line joining BC and for the line joining the points C and A. Moving on to the next problem. Find the direction cosines of x, y and z axis. Okay. So, we are finding the direction cosines, means we are considering a line and that line is actually making an angle of alpha, beta, gamma with the positive direction of x, y and z axis. And that alpha, beta, gamma, we are taking cosine, then we are taking it as direction cosine. Now here they are telling that find the direction cosine of x, y and z axis. That is, first let us find it for x axis. Means, here what I am doing is, I am considering a line on x axis first. So I am considering one more line on x axis. What is the angle made by this line with the x axis? Let us call that as alpha angle. The angle made by the pink line now, okay, with the x axis is 0. Okay. Next, what is the angle made by this line with the y-axis? See, now this line is overlapping on x-axis and we know that x and y-axis are mutually perpendicular to each other. So this is 90 degree. And similarly, the angle made by this line with the z-axis is also 90 degree. Therefore, even beta is equal to 90 degree and gamma is also equal to 90 degree. Therefore, cos alpha, which is 0, means cos 0, and cos 0 we know it as 1. Cos beta, which is cos of 90 degree, which is cos 90 is 0, and cos gamma, again cos 90 degree, which is again equal to 0. That is, the direction cosine of x-axis is 1, 0, 0. Similarly, now can you easily tell what is the direction cosine for y-axis? Means now what we are doing? We are considering a line on y-axis. Now what is the angle made by this line with the y-axis? It is 0. Then with the x-axis it is 90 degree. And similarly with the z-axis it is 90 degree again. Therefore, here the direction cosines will be cos of 0. Okay, that is cos of 90 degrees. That is with the x-axis. Alpha is with respect to x-axis. Therefore, alpha is 90 degree. Beta will be equal to 0 and gamma will be again equal to 0. Therefore, this will be equal to cos 90 degree, it is equal to 0. Cos of 0 degree, it is cos alpha, cos beta, which is 1, and cos gamma is equal to cos 90 degree, which is again equal to 0. The direction cosine for x-axis is 1, 0, 0 and for y-axis is 0, 1, 0. Then what will be the direction cosine for z-axis? We can easily tell the direction cosine for z-axis is what? 0, 0, 1. Again you can do, means we consider a line. So the direction cosines, here it is making, this line is making an angle of 90 degree. That is alpha is equal to 90 degree with x-axis and again 90 degree with y-axis and 0 degree with respect to z-axis. Therefore, the direction cosines for z-axis will be equal to 0, 0 and 1. Next question, find the direction cosines of the line which makes equal angle with the coordinate axis. We need to find direction cosines, that is L, M and N. They are telling that they are making an equal angle. Means alpha is same as beta, which is same as gamma. So that means cos square alpha is same as cos square beta and cos square gamma. Okay, we already know that. Okay, cos alpha we also call it as L. Therefore, I can write L square is equal to M square is equal to N square. Because cos beta we call it as M and cos gamma we call it as N. And we know that L square plus M square plus N square is equal to 1. So if L square is equal to M square and which is equal to N square, I can write L square plus N square plus L square only. Because L square is equal to M square. Again L square is equal to N square. Therefore 3 times L square is equal to 1. L square is equal to 1 by 3. L is equal to plus or minus 1 by root 3. If L is equal to plus or minus 1 by root 3, what is the value of M? Definitely M is also equal to plus or minus 1 by root 3 and N also equal to plus or minus 1 by root 3. And what is L, M and N? They are nothing but our direction cosines. Therefore, the direction cosines are plus or minus 1 by root 3, plus or minus 1 by root 3 and plus or minus 1 by root 3. Next, we need to show that these points are collinear. In order to show that these points are collinear, first let us find what is the direction ratios of AB, okay, and the direction ratios of BC. How to find the direction ratios of AB and the direction ratios of BC? We know that when we have a line joining the 2 points, say x1, y1, z1 and x2, y2, z2, the direction ratios will be given by x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2, or and z1 minus z2. Using the same formula, so the direction ratios of AB, direction ratios of AB will be given by x2 minus x1, y2 minus y1 and z2 minus z1. So let us find, so if this A and B, this call it as x1, y1, z1, x2, y2, z2, x2 minus x1, 1 minus 2, it is equal to minus 1, then y2 minus y1, minus 2 minus 3, minus 5, z2 minus z1, 3 minus of minus 4, so 3 plus 4, it is 7. Next, similarly, let us find what is the direction ratios of BC. Again, it is given by x2 minus x1, y2 minus y1 and z2 minus z1. Okay, so here Now we are considering B and C, so should consider this as x1, y1, z1 and this as x2, y2, z2. So 3 minus 1, it is equal to 2. Next, we have 8 minus of minus, it is 8 plus 2, which is 10. Then minus 11 minus 3, which is equal to minus 14. Now you see the direction ratios of AB and the direction ratios of BC are proportional. Yes, the direction ratios of AB and the direction ratios of BC are proportional. Therefore, I can say that AB and BC are parallel. Therefore, since direction ratios of AB and BC are proportional, we can say AB is parallel to BC. So, the line AB is parallel to BC. But here one more thing you should observe, the point B is common to both the lines. If a point B is common to both the lines, then it is understood that A, B, C are collinear. That is, the points A, B, C are all lying on a same line. Okay, since B is a point common to both AB and BC. So from this what you can conclude? You can conclude that A, B, C are collinear. Understood? In order to find this collinear, first I found the direction ratios of AB and BC. Then I told that these two are proportional. You can see they are proportional. Once they are proportional, we can say that these two lines are parallel. But here what we have observed is AB is parallel to BC means here you have a common point which is B. So if both means AB, BC, they have got a common point means it is understood that these 3 points are lying on the same line only. Next, again you have a similar problem. Again let us find what is the direction ratios for AB. So it is given by x2 minus x1, y2 minus y1, comma z2 minus z1. Therefore, minus 1 minus 2, it is equal to minus 3. Then minus 2 minus 3 minus 5, 1 minus 4, it is minus 3. Next, let us find what is the direction ratios of the line joining B and C. So it is now this is x1, y1, z1, x2, y2, z2. 5 minus of minus 1, it is 6. 8 minus of minus 2, 10. 7 minus 1, it is 6. Again you see they are proportional. Means minus 3 by 6, minus 5 by 10, minus 3 by 6 will all give you minus 1 by 2. They are proportional. Therefore, what you can conclude? AB and BC are parallel and B is a common point to both AB and BC. Therefore, this implies A, B and C are collinear. What is collinear? That is, these 3 points are lying on the same line.